Who wants a chance to win $500? In this video, we will be exploring the chances of events occurring. Some of the words you will need to understand are probability, theoretical probability, complementary events, A prime, the intersection of sets A and B, and the union of sets A and B. Probability is the likelihood of an event occurring. Theoretical probability is the possible number of ways event A could occur over the total possible outcomes. Complementary events is event A plus the complement of event A, and all that equals 1. The intersection of sets A and B are the things in both sets. The union of sets A and B starts with the things in both set A and the other things in set A and B. The first example uses a deck of cards. It states, Jeremy picks a random card out of a normal deck of cards. Find the probability that Jeremy picks up a red card. We know that red cards make up half the deck. So we can say that the probability of Jeremy getting a red card equals half of 52, which is 26. Part B states, given that Jeremy picked up a black card, find the probability that Jeremy picked up a spade. For this problem, we would use a tree diagram. Why don't you see if we can fill in the blanks on the tree diagram. The probability of getting a black card is 26 over 52. The probability of getting a spade is 13 over 52. Multiplying them together gets us an outcome of 0.125. Using our conditional probability equation in our formula booklets, we can find the probability of picking a spade given it was black. For example 2, we would use a graph to find the probability that someone took both subjects. I found the answer by trial and error until all the numbers inside the box added up to 40. I found that the probability that someone took both subjects is 12 over 40. Then, using our graph from part A, we can find B and C. The probability that someone takes calculus, but not algebra, is 9 over 40. The probability that someone takes algebra, but not calculus, is 15 over 40. Part D asks us to find the probability of calculus given that the student takes algebra. We would use the conditional probability equation in our booklet, which is probability of the intersection of A and B equals the probability of event A times the probability of event B given event A. Rearranging it to find the probability of event B given event A, we would get that the probability of event B given event A equals the probability of the intersection of A and B over the probability of event A. Then, plugging in the answers from B and the amount of students who take calculus to the students in the room, we get the probability of event B given event A equals 9 over 40 divided by 21 over 40, which equals 0.225 over 0.525, giving us a final answer of 0.43. For homework, you have these two questions. In bingo, find the probability that B is called. Given that B is called, find the probability that it is a B4. Question 2. Probability of A equals 0.5, probability of B equals 0.7, and probability of the union of A and B equals 0.9. Find the probability of the intersection of A and B. Then find the probability of the intersection of A prime and B prime. In bingo, there are 15 numbers to each letter. So we can say that the probability of getting a B equals 15 over 75 because there are 75 total numbers, which reduces down to 1/5. For question 2, we must use the combined events formula in our booklet, which is probability of the union of A and B equals the probability of event A plus the probability of event B minus the probability of the intersection of event A and event B, allowing us to solve for probability of the intersection of A and B. So we plug in all these things from the start of it. So 0.9 equals 0.5 plus 0.7 minus the probability of the intersection of A and B. So 0.5 plus 0.7 is 1.2 equals 0.9 minus probability of that. And then we subtract 1.2 from both sides, giving us negative the negative probability of the intersection of A and B equals negative 0.3. And then when we divide by a negative 1, we get the probability of event A. We get the probability of the intersection of event A and event B equals 0.3. For part B, we would also use the combined events formula. But before we use the equation, we would create a graph in order to find out probability of the union of A prime and B prime, which is 0.7. Then we would find the complements of A and B. We would use the equation from our vocab, probability of event A plus probability of A prime equals 1. Finding out that probability of A prime equals 0.5 and the probability of B prime equals 0.3. Then we would plug the information to the combined events formula and solve. So first we would add up the probability of A prime and B prime to get 0.8, and then we would subtract that from the probability of the union of A prime and B prime to to get negative 0.1, and then we would divide by negative 1 to get probability of A prime, the probability of the intersection of A prime and B prime equals 0.1. For part B, we would use a tree diagram. The outcome of B4 would give us probability of the intersection of 4 and B, which equals 15 over 5,625. Then, using the conditional probability equation, we can find probability of 4 given B. The probability of 4 given B equals 15 over 5,625 all over 1 divided by 75, which gives us 0.2. So probability of 4 given B equals 0.2.